Hello. Today we're looking at a quick recap of the index laws. These should be fairly straightforward, so I'm going to just give you a brief recap of what the laws say. We'll look at some worked examples and then a special case. So this one should only be quite a short video, just to give you a recap before you attempt the MathsWatch worksheets that are on SharePoint. So the first index law here is when we are multiplying two terms with the same base and a different power. Now, when I'm talking about the word index, that is the power here. So index is the singular. Indices, when you see worksheets and chapters of textbooks that mention indices, or if your teacher mentions indices, then that's talking about more than one of them. So here we have indices. This one here is an index. Okay, so it's plural, indices. Index is a singular. Anyway, so 2 to the power of 5 times by 2 to the power of 3. Well, a way of deriving this law is through examples. So this here is a specific example, and what I'm going to do is I'm going to write out 2 to the power of 5 and what it means. So it means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So that's 1, 2, 3, 4, 5 2's all multiplied together. Multiplied by, and then 2 cubed is 2 multiplied by 2 multiplied by 2. So I've got 5 of them here multiplied together, and I've got 3 of them here multiplied together, and I'm multiplying all of those together, so in total I have 1, 2, 3, 4, 5, 6, 7, 8. So this here is 2 to the power 8. Now you don't need to write all of this in, this is purely just to illustrate what's going on here. What we can actually do is we can just add the powers, so 5 add 3 gives me 8, and we'll see that in our worked example in a moment. We don't need to write all this down, we can just write the answer straight down without having to write any of this sort of intermediate step. Same works here for division. So I'm going to write 5 out 4 times. So 5 multiplied by 5 multiplied by 5 multiplied by 5. So that's 4 of them. And then I'm dividing this by 5 multiplied by 5 multiplied by 5. Now you should see here that what I've done is I've written the division as this line instead. This line is actually called a vinculum, but either way, this line here as like a fraction line, it means divide. So if I've got the fraction 1 half, 1 over 2, that means 1 divided by 2. Divide 1 into 2 pieces, I get 0.5 in each piece. That's why a half and 0.5 are the same thing. This division symbol and this line here are the same thing. Anyway, so if we look at what we've got now, top and bottom, we can start cancelling some things out. So I'm going to cancel a 5 and a 5, I'm going to cancel another 5 and another 5, top and bottom, and then finally one more top and bottom. So I've got one single 5 left, 5, like 5 to the power of 1, or just 5 if you prefer to write just 5. Here, again, the rule is, if I'm dividing, the bases are the same. If I'm dividing, I subtract the powers. So 4 take away 3 gives me 1, which is here just 5. Finally here, this third rule is just a special case of the first rule. You've got to remember that raising something to a power is just that idea of repeated multiplication. Here we had 2 to the power of 5, that's repeated multiplication, multiplying by a 2 multiple times. So here 6 squared cubed, that's just 6 squared multiplied by itself 3 times. So that's 6 squared multiplied by 6 squared multiplied by 6 squared. So that's 3 of them, 6 squared, 6 squared, 6 squared, multiplying by itself 3 times. Now we can look at that first rule. That first rule was that we just add the powers. So 5 add 3 gave us 8 in the first example. Here 2 add 2 add 2 is going to give me 6. So this here will be 6 to the power of 6. So again here you don't need to write this intermediate step out. It's just here to illustrate. But the rule here is if I've got something to the power, the base to the power, raised to the power again, then all we do is we multiply these powers. 2 times 3 here will give me that power of 6. So let's have a look at a couple of worked examples and just sort of see how this works, and then we'll have a look at our special case here at the bottom. So this first one here, a to the power of 4 multiplied by a to the power of 5. If I'm multiplying, the rule is that we just add the powers. So this here will be a to the power of 9. The base doesn't change. So if we go back to these examples up here, just as a reminder, the base here of these was a 2, it stayed as a 2. The base here of these was a 5, it stayed 5. The base here was a 6, it stayed as a 6. It doesn't change. What a lot of people will do is they'll go, I remember the rule, 5 add 3 gives me 8, and then they'll do 2 times 2 and they'll rewrite the base as 4. The 8 tells me how many 2's I am multiplying together. the 2 doesn't change to something else, it stays the same. So that 2 there was the base, it stays as a 2. Same thing here, I've smudged it now, but same thing here. The base was an A, it stays as an A. Here the base is a B, it stays a B. So then we look to our rule, it's division, so that means we're going to take away. So 9 take away 3 is 6, this one here is B to the 6. Here you'll look and think, oh no, they're trying to complicate things now, and there's a common mistake that people will make here. They go, oh, hang on, I know this, I'm going to have X, and 2 add 5 is 7, because I can do that, that's easy. And then they'll go 2 add 3 is 5, and they'll write 5 in the front of this, because they've got into the mindset here of adding things together. We're only adding the powers because I've got 7 x's in total multiplied together. The instruction here is to multiply, so I'm doing 2 multiplied by 3, which is 6 out the front. And the same thing happens here in this fourth example. Here I've got something raised to the power of 4, so I'm going to have x cubed raised to the power of 4, and as we know that will be x to the power of 12 because we multiply the powers. 3 times by 4 will give me the 12. And then we're also doing 2 raised to the power of 4. Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So 2 to the power of 4 is 16. We don't do 2 times 4 and get 8 out the front here. We do 2 to the power of 4, which gives me that 16. Now this special case here is a special case of the second rule, and it's something that I made a big deal of when I looked at this in class with you. So we've got 5 squared divided by 5 squared. Well, that's going to be 5 to the power of 0. Well, we always want to be thinking, what does something to the power of 0 mean? And the common answer is, well, 5 to the power of 0 is just 0, but it's not. If you think about what 5 squared is, that's 25. If I divide 25 by 25, if I divide something by itself, I get 1. So that means that 5 to the power of 0 must be the same as 1. They are the same thing, because these two things here, 5 squared and 25, this is the same calculation. 5 squared divided by 5 squared, 25 divided by 25, they are the same calculation. They give me answers of 5 to the power of 0 using our rule. 2 take away 2 gives me 0. But they also give me an answer of 1. 25 divided by 25 is 1. Anything divided by itself is 1. So that means that anything to the power of 0 equals 1. So I can have x to the power of 0. I'll get 1. I could have 0.2 to the power of 0. I'd get 1. I could have minus 3 to the power of 0. I'd get 1. Okay, it doesn't matter. Anything that I've got to the power of 0 will give me 1. And that's all there is. So what you want to be doing is having a look at page 154 of the MathsWatch worksheet that is on SharePoint. If you've got any questions, then just drop me some comments on the video, or send an email and I'll give you a bit of a helping hand.